Okay. So in today's session, we are going to learn about selection of VB. Hello. Selection of V-belt and pulley. So the problem statement here for today's discussion is a V-belt drive required to transmit 15 kilowatt power from a motor 1440 rpm electric motor which drives a centrifugal pump running at 360 rpm for a service of 24 hours per day. So it is a continuous service. From space considerations, the center distance should be approximately 1 meter. Determine the belt specification, number of belts, and correct center distance. Okay, so in this given application, we have power need to be transmitted, that is 15 kilowatt. That 15 kilowatt power need to be transmitted here. Motor speed from which this power is derived. So the motor is running at 1440 rpm, and centrifugal, the application which is a centrifugal pump here, the pump speed is 360 rpm. The approximate center distance here is 1 meter, that is 1000 millimeter, and service hours are here 24 hours per day. Okay, so now we will use PSG methodology for V-belt selection. So first type you have to, whenever we take any application, we need to identify the type of belt to be used here. So since it is V-belt, so first is the selection of type of belt and minimum pulley diameter here. So input requirement here is power, so which is given as 15 kilowatt here. In this problem, the power requirement is 15 kilowatt. That is, we are transmitting here 15 kilowatt power. So for this given power, let's identify the right section of the V belt. So there are A, B, C, D, and E. Five sections are available. So based on your the power to be transmitted, you can select the type of belt here, type of section. So here 15 is included in two series for section B as well as section C. But section B, it is included on the extreme side. So that is the last limit. The last limit value. So the correct value will be between 7.5 to 75. So we can select here type C section, which may cover the extra power required for the transmission also. So here if you select type B, then the limiting value is 15. So if you require say 17 or 18 kilowatt, then this cannot be used there. So if it is a overload in the application, so the power requirement will increase there. Just when Sorry for disconnection. So we are selecting section C because our given power lies between 7.5 to 75 kilowatt. So we can select section C. So the C demands for a minimum pulley diameter of 200 mm. So minimum pulley size should not be less than 200 mm. These are the sizes, the top width of the belt and the thickness of the belt. Thickness of the belt is 14 mm and top width of the belt is 22 mm. So let's select section C and 200 mm pulley diameter. Minimum pulley diameter is 200 mm. So in the next step, step 2, we are identifying the speed ratio. Speed ratio here is equal to I is equal to N1 upon N2. That is 1440 upon 360. So there is a speed reduction here from N1 to N2. So speed reduction ratio here is 4. So determining the larger pulley diameter, because smaller pulley diameter is based on the earlier relation there. So larger pulley diameter, capital D is equal to I into D. So I here is 4, speed reduction. So larger pulley diameter will be increased by 4 times here. So 200 into 4, so it will be 800 mm. So this is the larger pulley diameter. Smaller pulley diameter is 200 mm. Small d is equal to 200 mm, which is taken from the table value. Now we need to select approximate or fixed center distance here. Let's assume our center distance is not fixed. Let's say we want to vary the center distance to accommodate the pitch length. So approximate center distance given in the problem is 1 meter, that is 1000 millimeter. Now there are the formulas for C minimum and C max. C minimum formula, this is given in the PhD data book. I will show this formula where it is taken from. C minimum is equal to 0.55 D plus D plus T, and C max is equal to 2 times D plus D. So where these formulas are taken? So these formulas are taken from PhD data book, page number 7.61. So let's see the page number. Yeah. Page number 7.61. Here is the page number 7.61. These are the formula given here. For 0.55 in D plus T is the thickness of the belt here. C max 2 into D plus D. So given center distance, our selected center distance should lie between the C minimum and C max value. So let's do the calculation here. So after doing this calculation, C minimum, that is 0.55 into 800, capital D is 800, small d is 200 table value. So this comes out to be 564 millimeters. So your distance cannot be less than 564 millimeters. This is the minimum distance, and maximum distance 2 plus D plus D, that is equal to 2 into 800 plus 200 plus 2000 millimeter, and your center distance should not be greater than C max value, that is should not be greater than 2 meters. What happens if the center distance is less than C minimum, or what happens when the center distance is greater than C max? If the center distance is less than C minimum, then assembly of the belt between two pulleys, there is a chances the pulleys may touch to each other, as well as the angle of contact on smaller pulley when the center distance is minimum and the speed ratio is large, the angle of contact on the smaller pulley is very small. So that will decrease the chance, that will increase the chances of slippage of the belt. Uh, Second, if your center distance is too large, that is, it is greater than say C max value, the belt has its weight. I'm showing that weight density also. You can see weight per meter kgf. So as you enhance this value of A, B, C, this density of that belt material is increasing here. So if If your C value is greater than C max value, then the weight of that belt will cause large amount of centrifugal forces, and there is a large amount of sagging length, so which will cause additional centrifugal tension or centrifugal stresses into the belt, and that may decrease your power transmitting capacity for the belt. So to maximize the power transmission with a minimum of stresses, then C has to be between C minimum and C max. So this condition has to be satisfied. C minimum, C your selected C value should be greater than C minimum but less than C max. So problem statement, it is given 1000 millimeters. We can select the correct value, approximate value around 1025 mm. You can select this, but that will cause a problem that I'll explain when we are solving the problem further. So let's select this value as 1025 mm. We have taken 25 mm extra. So we are taking center distance, variable center distance of 1025 mm. Okay. So next, we used to calculate the pitch length of the belt and oblique center distance of the drive. Now here we are calculating pitch length of the belt by considering fixed center distance. So pitch length of the belt, this formula is equal to L is equal to 2C plus pi by 2 into D plus D plus D minus D bracket square upon 4C. So this formula is also available on PHG 7.61. So in this formula, we are writing around the center distance value, which is approximated at this moment, is 1025 mm. Okay. So if you can take this 1000 also, but this value will be then very, very small. So why we have to take 1025 or greater, or sometimes you have to take lesser also. You have to take then 975 also in some cases. So here I am taking 1025. I will explain after doing this calculation. So now in this formula, center distance is 1025. Capital D is 800 mm and small d is 200 mm. So therefore, L is equal to here. This is the pitch length of the belt at the pitch point. 2 into 1025 plus pi by 2 into 800 plus 200 plus 800 minus 200 bracket square upon 4 into 1025. So this pitch length comes out to be 3708.60 millimeters. Now, this is the pitch length, calculated pitch length for considering 1025 mm center distance for given diameter of pulleys. Now we have to select the standard pitch length from the table. So this may not be available in the table. So let's go to the page number 7.60. Okay. So this is your page number 7.60. Okay. So you can see here the specification of this nominal pitch length here. This is the nominal pitch length, which is right now we have calculated. So we have to select a cross section C. Cross section C. Our value is 37007. So you have to select the standard pitch length value nearer to that. So 3707 means the nearer value is 3713. Nearest value for section C here is 3713. So corresponding nominal inside length, the first column here, is called the designation of that belt. First column of this table is the designation of the belt. So for corresponding 3713, corresponding designation here is 3658. So what is meaning of this 3658? The 3658 is nothing but nominal inside length of that belt. So if you select pitch length of 3713, it will have 3658 inside belt length for cross section C. So we are selecting here 3713 pitch length, and we are selecting here nominal inside length as 3658. So my designation here is C3658. So designation of my belt is this now. It is C followed by inside nominal is 365. Okay, so with this, whether our selected application gives the right result or not, let's check. So next, we are going to calculate the grade of your belt. Okay, so we have 3708, corresponding value was 3713 in the table. So for this corresponding value, nominal inside length belt was 3658. So this 3658 is nothing but your designation of the belt. Now, still we are not finalized the designation of the belt. This is the initial designation of the belt. So let's go for the finalizing the designation of the belt. So next step, now we are coming here, designation of V belt. Step 4, we are finding out what is the final designation of our belt. So for input is here the calculated pitch length. Now, in this calculated pitch length, sometimes you need to account for initial tension. So your pitch length, calculated pitch length has to be reduced by some small amount up to 0.5 to 1% length. So we are considering here, so that is with and without consideration for initial tension. Let's consider initial tension. So considering the reduction in the pitch length to account for initial tension. So let's reduce the length of the calculated length. So calculated pitch length now finally will become length required minus correction. Okay. So length required is say L. Correction to be applied here is 0.5%. Maximum correction you can apply is up to 1%. So let's say take a minimum correction as 0.5%. So L minus 0.5% into L. So that comes out to be, so when you put the value of calculated value 3708, so we get this value as 3690.05. Now this value again, if you see the table, this value, the nearest value for this again is 3713. If after doing this calculation, if your nearest value is changing, then you have to change the designation of the belt also. So in the designation of the belt, the nearest value is also same, that is 3713. So for this length also 3713 is the nearest pitch length value. So designation of the belt, the formula here is here, rating formula, 50 plus calculated pitch length upon standard pitch length upon 2.5. Now 50 is the base value, so 50 value will be written here. Calculated pitch length is this. So calculated pitch length considering initial tension. So considering initial tension, that is 3690.05. So 3690.05. Standard pitch length. So nearest to this standard pitch length was 3713 in the table. So we have divided by standard value of 2.5. You read 2.5 length, millimeter length. Grade will change by one value, either positive or negative. Now here it will become negative because your calculated length is lesser than the standard pitch length. So this calculation will come negative here. So 50 minus that negative value comes out to be 40.82. So this value will be rounded to the nearest number. So this is very close to 41. So this will be rounded to 41. So your designation of the belt now will become, designation of the belt is C, that is the type of section. Inside nominal length corresponding to the standard pitch length of 3713, that is equal to 3658 is the first column of that table. Dash your rating, that rating, rounded rating here, rounded rating value is 41. So the belt here, belt designation is C365841 dash 41. So C inside nominal length 3658 mm and grade of that belt is 41. So you have to select the belt having inside nominal length C section belt having inside nominal length 3658 mm and grade value should be 41. So this is printed on the belt top surface. Please remember this grade is always printed on the top surface of the belt. So when you buy belt from the market, you have to see what is the grade mentioned on the top surface of the belt. Okay. So in this problem, you have been asked to determine the correct center distance. Whatever we have choose that center distance was approximate center distance. Now we have finalized the your C value. You have finalized the length of the belt. What is the length of the belt required here? So based on that, you will have correct center distance. Correct center distance formula C is equal to A plus under square root A square plus B, where A is equal to L by 4 in minus pi into D plus B upon 8. So when you put this value of L, calculated value here, L 3690, B and D value here, so we get this value as 529.8 millimeter. And this B value is equal to D minus D square upon 2, 8. So these formulas are from again from 7.61. Page number 7.61, the value of A and B formulas are given. So B comes out to be 45,000. So when you put this value here, and if you do this calculation, you require the exact center distance for this belt, because based on the belt designation, the center distance will change here. So you required for a 3658 41 grade belt, you required a center distance of approximately 1,100 millimeters. Again, if you see this value is not far away from the approximate center distance given in the problem. It is around 1 meter. Here it is now 1.1 meter. So it is just varied by 10%. So your selection of this belt and this correct value of center distance, you can change and you can position your shaft to the 1.1 meter distance. Okay, so that will give you the proper working of this belt. Otherwise, what will happen if this center distance is not corrected? Then the power transmission will not be appropriate. There is a chances of belt slippage, or either belt will be slip if there is no initial tension, or if the belt has very high initial tension, there is a chances your belt may break also. So to avoid the slippage or breakage of the belt, the center distance should have variable. So in most of the V-belt applications, there is a positioning element. The shaft, the center distance can be varied to some extent. It can be varied up to 1.5% of the total distance there. So you can take this distance fixed to 1,100 millimeters, and you can keep a small variation in this around 1% to 1.5%. So you can go 1% of this means around 10 mm plus minus. So 1,100 mm plus minus 10 mm center distance has to be fixed. Otherwise, your drive will not work properly. Okay, so this is regarding the designation of the belt and the correct center distance. So we have identified the designation of the belt required for the problem as well as the correct center distance. Let's go for the number of belts calculation now. So before going for number of belt calculation, you need to calculate the power rating for given belt. So power rating formula, you can use this formula table available in the PhD, or you can use the tables available on page number 7.63 to 7.67. At this moment, I am using formula, but I will show how to use table also. So let's say our belt section is C. So the formula is here, and this formula is applicable up to smaller pulley diameter or equivalent pulley diameter up to 300 mm. So let's evaluate the equivalent diameter for this C section here. Equivalent diameter here is the smaller pulley diameter into formula means the correction factor for small pulley diameter FB. So smaller pulley diameter is we have selected 200 mm. FB we have to select from the table, so that I will show how it is selected. So FB is selected based on your I value, that is the speed ratio value. So speed ratio here is 4. So let's go and select the FB value from the table. Okay. We have selected. Yeah. We have selected this section C. So in this formula, we require this equivalent diameter. So that equivalent diameter is equal to dP into FB. dP is 200 mm. So FB value, this table is available. So this table value gives for various speed ratio here. Our speed ratio is the maximum one, that is equal to 4. So it is beyond this table here. And anything, if speed ratio is greater than 2.9, means almost greater than 3, the FD value is 1.14. So FD value is 1.14 here. I take it up so we can see here. FD value here, the smaller diameter pulley factor here is 1.14. So selecting this 1.14 pulley factor, we are calculating DE now here. So DE here is 200 into 1.14. So that comes out to be 228. And this value, whatever calculate, if it is turning greater than, this formula cannot be used. Okay, then you have to go for table value. Belt speed, we get the belt speed is equal to 15.07 meter per second. Now, belt speed S value in terms of meter per second. S raised to minus 0.09 minus 142.7 upon DE. DE has to be taken in millimeter here. Don't take D in meter here. Take in millimeter. Minus 2.34 into 10 raised to minus 4 into S square, and whole bracket multiplied by S here. Okay, so let's put the values of S and DE here. So we have got 1.47 into 15.07 into raised to minus 0.9, and putting this value of D here is 228. S is equal to here 15.07. The rating, power rating of V belt, single V belt, is equal to 7.1212. This is the power rating of the single V belt, 7.1212 kilowatt. Now we need to determine number of belts here. So number of belts, the formula here, before going for number of belts, we need to find out the angle of contact on smaller pulley and the correction factor for arc of contact. So angle of contact here is 180 minus D minus T upon C into 60. So 180 minus 800 minus 200 upon 1025 is we have taken there into 60. This comes out to be 144.87, that is 140, approximately 145 degree. And this correction factor for angle of contact for 145 degree is around 0.91. I will show this value also from the table. This value is available here. Yeah. This table value is available here. Formula for arc of contact, and then based on the arc of contact, the correction factor for V to V. We are considering V to V pulley here. So for 145 degree, approximate value of 145 degree angle of contact, the correction factor, angle of contact correction factor is 0.91. So FD value here is 0.91. Okay, so let's take this value in the calculation. Then number of belts formula is equal to power P into FA upon power rating for single belt into FC into FD. This formula. This kilowatt is the power rating of single belt, which is right now we have calculated in the previous slide. FA is a service factor. FC is your correction factor for the pitch length, and FD is your correction factor for the arc of contact. So FD is already calculated, that is 0.91. Rated power here given here is 15 kilowatt. FA correction factor according to industrial service. Now here your application is centrifugal pump, and which is running for 24 hours per day. So based on drive and driven characteristics, this value of service factor comes out. This also comes from a table. I will show that table also. Service factor table here. Here, this is the service factor table. This is the driving unit characteristics, and this is the driven unit characteristics. So the intersection of these two will give you the service factor here. Now let's consider your drive motor is a electric motor, AC motor here, normal AC motor, running for say 16 hours. So this column has to be referred. Then you are considering here centrifugal pump. So you can consider light duty, medium duty, or heavy duty. Let's say consider light duty application because your load is up to 15 kilowatt or say up to say 10 kilowatt. You can go for light. Above 10 kilowatt, you can go for medium duty. Let's take a light duty application because it is centrifugal pump running at constant speed. So let's take this value. So we get the service factor as 1.2. Somebody can select medium duty application, then your service factor will be instead of 1.2, it will be 1.3. But here you cannot take heavy duty application because pumps are not considered heavy duty unless they are used for city supply. So then they will be either medium duty or light duty application. So I'm considering light duty application with 1.2 service factor because it is running more than 16 hours. So continuous service of 24 hours is there. So we'll consider service factor as 1.3 here. Then we have another factor called pitch length correction factor. So pitch length correction factor is available in the pitch length table. That is 7.60 table we have referred currently here. In this table, the correction factor is there. So our belt is C3658. So C3658. So for this correction factor for C belt here, you can see correction factor FC here. For C3658, it is 1. So FC value is equal to 1 here. So we have taken both the values now. Okay. So we have service factor 1.2. FC is equal to 1 from the table. FD is equal to 0.91 again from the table. So let's calculate number of belts. Number of belts required here is equal to 15 into 1.2 upon 7.1212. This is single power rating, single belt power rating into 1 upon 0.91. So we require number of belts here around 2.77, which is approximately equal to 3. So you require number of belts here for transmitting 15 kilowatt power. Approximately 3 belts are required of C section having rating C365841, having grade 41. Now I was explaining that this kilowatt rating, that previous slide, if we go to the previous slide, this kilowatt rating also can be calculated or read from a table. Instead of using this formula, you can directly calculate from use a table, and from that table you can get this value. You may need to do some interpolation in the table. So let's see how you can be. Your value has come around 7.12. Let's see how you can refer in the PhD data book. Now these are the power rating tables. This is the power rating table for section A belt. Ours is in section C belt. So we will refer the section C table. Section B. This is in section C table. You can see this is a section C table. Equivalent pitch diameter. We have calculated our equivalent pitch diameter is around 228. So it is between 220 and 240. So equivalent pitch diameter here is between 220 and 240. ये दोनों के बीच में. Then your belt speed is 15 meter per second. So if you go and take the 15 meter per second, so 15.07 meter per second. So this value is 15 meter per second. So if you see here, our value is between 220 to 240 and 15 meter per second. So our value is between this value 6.77 to 6.758, 7.58. If you see our calculation, Our calculated value should be between 6.77 to 7.58. So when you use this table, you need to do some interpolation, and then you can get this value of power rating for single V belt. But this is an approximate value. If you use that formula, then it is an exact value. You will get the exact value of power rating. So try to use formula. If formula is not acceptable, suppose if your DE value comes greater than the DE value mentioned in that table for the formula, then don't use that formula. Then you go for the selection from the table here, section C table or section D table, whatever the table section you have selected here. So this comes out to be 7.1212. So you can see here our value is, should be greater than 6.77 and less than 7.58. So we get that value as 7.1212 based on the, if you take average value also here, so that value is around 7.1. That value is around 7.1. Okay. So this is used in the calculation here. So whatever the we get here 7.12, that is also you can read from table. You can use this formula or you can read from the table also. I think you may have understood this is a very critical step. If you make this mistake, then your number of belts will go wrong. Okay, because that number of belts will decide the geometry of your pulley and the size of the pulley also. Okay, next step is to determine the pulley size here. So this is the pulley cross section. This is the entire face width of the pulley. This is your center distance between two V grooves. Number of V grooves depends upon the number of belts here. So we require 3 belts. So there will be 3 V grooves here, 1, 2, and 3. We required certain dimensions here. So pitch width of the pulley, this is available from the table. So pitch width of the pulley, that is the distance here, this pitch width. So, this point to this point distance, that is called pitch width. That is equal to 19 mm. That is available in the table. Then minimum depth below the pitch line, that is this distance H here, below the pitch line. How much V groove depth should be there? So that H is also available from the table. That I will show that table also. The distance between two grooves, this point to this point, this distance is also available from the table. That is given as 25.5 millimeters. So let's see this 19, 14.3 and 25.5, how they have come from the table value. I will show the table also. Here, this is the cross section of the V belt pulley. Now our section is C. So pitch width should be 19 mm. Pitch width is 19 mm. That I have written in the calculation. Then minimum distance down the pitch line, that I have not written, but that is this distance. The top surface of the pulley and the pitch line up to the pitch line of the belt. This distance is called B. So this distance should be equal to 5.7 millimeters. Then H, that is the pitch line to the bottom of the V groove. So that distance for section C should be equal to 14.3 mm. And the center distance between two V grooves here, that is E value here. So that is equal to 25.5 millimeters. So these sizes are coming from this table. Since we have used C section, you have to use C section type pulley only. You cannot use A and B because their angles are different and their sizes are also different. Then the mating means the pulley belt will not fit into that V groove properly. Either it will fit on the bottom surface if it is you are selecting D. If you are selecting A pulley, then it will be, this belt will be away. It will be outside this surface. Ideally, for ideal application, the top surface of this belt should be lie below the top surface of the pulley. Theoretically, it should be exactly in line, but practical application, this surface should be slightly below this surface, so that even wear of the surface, the lateral surface here, which is in contact with the pulley surface, even wear will happen. Otherwise, uneven wear will cause the belt to wear at a particular location faster, and other location there is no wear. Okay, so this is the dimensions we are calculating in using. So from this you can calculate the maximum diameter of the pulley also. I have not done that calculation. This is the pitch diameter we know. That pitch diameter we have calculated. Above that you can add B on both sides. That is 2B added. You will get the larger pulley diameter. What is the larger diameter of that pulley in the calculation here. Okay, so face width of the pulley. The face width of the pulley is this equal to L. So how many V grooves are there? That's center distance. Now there are 3 V grooves. So E will be 2 times. E will be 2 times. Then there will be one left end. There will be a distance R, and right end there will be distance R. So this L face width of the pulley will be 2E plus 2R because there are 3 belts here. That's why 2E. If there are 4 belts, then this will be 3E plus 2R. If there are 2 belts only, then it is 1E plus 2R. So E is given here 25.5. So 2 into 25.5 plus 2 into R. Now how much R should be taken? The R value should be greater than this E by 2. R value selected here, and on this side here, from this point to this distance here, R should be greater than E by 2. So E is how much? 25.2. So that comes up to be 12.65. So I am selecting R here is 15, which is greater than E by 2 here. So R value should be minimum equal to E by 2, but in practical application it should be stronger. So R value should be greater than E by 2. So 2 into R, that is 15. So we require the minimum face width of the pulley equal to 81 mm. So we can mount three belts on this V belt pulley. So you will require 2 pulleys here. One smaller pulley to be mounted on motor shaft, and one bigger pulley to be mounted on the pump shaft. So both should have face width equal to 81 mm, and other dimensions are also same. So this is your final dimensions for your pulley. So that completes your problem. So if you have any difficulty, or if you have not understood why we have selected kilowatt rating, how we have calculated, you can unmute yourself and ask that out. Okay.